Here's an additional example of a word problem involving rate of change. The graphs of many functions are not linear. And as we can see, this graph right here is not a straight line function. It's a curve. It goes up and it comes down. But in a short interval or in a small interval, I'm going to go ahead and read this. However, we often use linear approximation to analyze nonlinear function in a small interval. Okay, in a small interval. Okay, so pick 2 points that are pretty close. For example, I can look at the time in between 1 hour and 2 hours, and the line that I can sketch through these 2 points, look, that line is isn't that very close to the actual curve, right? So for in a small interval, we can use something called this linear approximation. Okay, so but you don't want to do, like, for example, you don't want to pick a point at 1 hour and point at 8 hours and draw a straight line, because that line is far from the actual blue curve, right? So you want to start with, or you want to actually just work with small intervals from like 1 hour to 2 hour in this example. All right, let's take a look. For example, the graph below shows the blood alcohol concentration, BAC, for an individual over a period of 9 hours. So a person drinks, their blood alcohol concentration goes skyrocket up, and around like right before 3 hours is the highest, right? And then the alcohol goes away. So probably, like, I can't remember what the safe, let me see. BAC for driving. Blood alcohol level for driving. They said after 0.0 and 0.08 is the federal limit of legally drive in the United States. So it has to be below 0.08. So like right there, this person should not be driving in between like hour and 30 minutes, and then like what's this, 4 hours. So either you drive, I'm not suggesting that you drink and drive immediately. No, you probably shouldn't, but you're gonna have to wait after like 4 hours and then like sober up, and you can probably drive home. But all right, what am I doing? Let me erase this. Let's just answer what they are asking for here. Okay, so it says a line drawn through 2 points on a curve is called secant line, and that's something that we talked about during class. Okay, we said, like, if a line goes through 2 points, we call that a secant line. If it just goes through 1 point, we call that a tangent line. So if you draw 2 points, point 1 and point 2, and draw a straight line through them, we have a secant line. We can find the slope of the secant line to do a linear approximation. Okay, so what are they saying? Let me keep on reading. In figure above, the average rate of change in BAC between 2 points on the graph is the slope of the secant line through the points. Okay, notice that the slope hold on, it went away. Lost connection for a while there. Okay, so I'm back. Alright, I'm gonna skip reading this part. Okay, so what do they want? Determine the average rate of change of blood alcohol level from x of 1 equals 0 and x of 2 equals 1. So what they are asking is, how is the blood alcohol level changing on average from 0 hours after drinking to 1 hours after drinking? And I can see the lines going up, right? The blood alcohol concentration is going up. So the average rate of change is going to be a positive number. So let's see, let me read the order pairs, okay? So when x is 0, y is also 0. How do I know that? I read the order pair here. The order pair is 0, 0. So when x is 0, y is 0. What about when x is 1? When x is 1, y is 0.06. 0.06. So I identify the 4 numbers that I need to work with to find the average rate of change. Remember, if you watched the first review video on slope formula, you know how to find the slope. The average rate of change is equal to you have to subtract the y values on top, the output values. So I'm going to do 0.06 minus 0 on top of the fraction. 0.06 minus 0 on top of the fraction. How about the denominator? We're dividing this by the change in x's. 1 minus 0. 1 minus 0. Now, if you simplify this fraction, what's that going to be? That's going to be 0.06, right? Now, if I try to put some units here, I can do percentage point per hour. So it's positive. It's going up by 0.6, 0.06 percentage point per 1 hour. That's exactly what happened, right? From 0 second or 0 hour to 1 hour, the blood alcohol concentration raised from 0 to 0.06. So let's fill in this blank over here. It says the blood alcohol concentration rose by an average of 0.06 percentage point per hour during the first hour. So it was going up somewhat rapidly. All right, how about they're asking you to find, what about from x of 1 equals 0 from 1 hour to 2 hour period? I don't know, I have to read their y values first. Oh, I do know for when x is equal to 1 at 1 hour, the BAC was 0.06. But I need to go up to the graph to see the BAC after 2 hours. Okay, what's that going to be? After 2 hours, do you see that the blood alcohol concentration is 0.09? So that's the y value that I'm going to have to work with. 0.09. So I wrote these down. Now let's go ahead and find the average rate of change. What is the average rate of change? I have to subtract the y values and put that on top. I do 0.09 minus 0.06. 0.09 minus 0.06. I wrote too big. In the bottom of the fraction, I have to subtract the x values. I have to do 2 minus 1. 2 minus 1. If I do that, I'll be able to simplify and get the rate of change. Let's see what that is. The numerator will be what? 0.03. 0.03. The denominator is just 1. So the final answer is simply 0.06 percentage points per hour. Okay, so that's it. And I don't think I'm going to write the unit here because we can fill in the blank down here. So the blood alcohol concentration rose by an average of 0.03 percentage point per hour during the second hour. So it's somewhat slowed down, as you can see, right? In the first hour, it rose up like twice as fast as the second hour. Okay, so that's how you can find the average rate of change by reading points off of this graph, okay? So that's it for, I think that's it for this video. Yup. I'll talk to you later.